Hey guys, so this video will help you simplify radicals. I'm going to show you multiple ways and then you'll find whichever way helps you the most. And you'll stick to that one way. You will not go flip-flopping. You stick to one method that helps you get to the answer every time. Alright, so I have to simplify the square root of 100. The first way I'm going to show you is putting it into prime factorization form. And so what you'll do is you'll look at this number and see if you can find any factors. And factors are two numbers that will multiply to get you this number here. 25 times 4. It doesn't matter which ones you start off with. 10 times 10, it doesn't matter. 2 times 50, it doesn't matter. Alright, so I chose to start off with 25 and 4. Now, I'm going to look at these factors and see if I can break these factors down any more into prime numbers. So I'm going to see if I can break down 25 and find numbers that multiply to get 25. And I'm going to keep going until every number is broken down to a prime number. And a prime number is a number that can only be multiplied by 1 and itself. Five times 5. Let me see if I can break down 5. Cannot break that down, so I'm going to circle it. I can't break down 5 anymore because 5 is a prime number. The only factors that'll get you 5 is 1 in itself. 4 can be broken down. 4 is not prime. 4 can be broken down to 2 times 2. Can 2 be broken down anymore? Nope. It's just 2 times 1. And this is also prime. So now that I know all the prime factors of 100, I'm going to rewrite the square root of 100 as the square root of 5 times 5 times 2 times 2. That is 100 in prime factorization form. If I was to take my calculator and I was to actually multiply 5 times 5 times 2 times 2, I'll get 100, which is what I started with. That's how you can check yourself to make sure you really do have it in prime factorization form. So now what you're going to do is you're going to look here and you're going to figure out, okay, I have these numbers, I have these prime numbers. I didn't change the problem at all. I still have the square root of 100. But now that I have these prime numbers, I'm going to think about married people. You marry someone you have something in common with. You marry someone that you identify with. These 5s are exactly the same. They're the perfect match. So what will happen is they'll get married. And you know that there will only be 2 in this group because this is the square root. So there's an imaginary 2 there. So I know I'm going to circle 2. Later on you'll see that you'll have a cube root. A cube root means that you'll have to have 3 of the same numbers. But in this case it's a square root, so I need 2. I have my 2. And this will come out of the house as 1 5. Think about it as marriage again. When you get married, you move out of your house, your mom's house, and you are now in one house. You have one last name traditionally. You are identified as one family. So they are no longer separate 5s. They're considered 1 5. These 2s, perfect. They'll move out of the house as 1 2. So when I'm looking at this, I have my house. Outside of my house, I have 5 times 2. And inside my house, I have whatever was left over, the people that didn't get married. They're sad. They couldn't really find anybody to get married to. In this case, they all got married. It's a happy family. There's nothing under the radical. So I can just go ahead and get rid of my radical. And now I have my answer. 5 times 2 is 10. And you already knew that the square root of 100 is 10. I just wanted to show you how it really works. So when you get to a number that is not perfect, you can do it. But before I move on to the next example, I want to do this same example again. And I'm going to use different numbers to show you that it really doesn't matter which numbers, which factors you start off with. So in this case, I'm going to do 2 times 50. It doesn't really matter. I told you in this example it doesn't. I'm just proving it now. Alright, 2 cannot be broken down anymore. It's a prime number. So I'm going to circle this. And I'm going to see if I can break down 50. And I can. 50 is 2 times 25. Can I break this one down? Nope. Can I break this one down? Yes. 5 times 5. Can I break this down? Nope. It's a prime number. Only 5 times 1. Can I break this down? Nope. So if I was to rewrite this square root of 100, you'll notice I get the same prime factors. I get 2, 2, 5, 5. And then from there you circle your groups of 2 because it's the square root. So I know 2 are going to go in a group and come out as 1. So 2 2s will come out as 1 2. 2 5s will come out as 1 5. So you'll have 2 times 5. And you'll get your same 10. Alright, so that's the long way. That's the way if you are not comfortable with putting numbers into prime factorization form. If you're not comfortable with just simplifying it and finding square roots, that's the way to go. The shortcut way is to understand what square root really means. Square root means you're going to have 2 numbers that multiplies same identical numbers, multiply times itself to get this same number, this number right here. So what I mean is, what 2 numbers can you multiply to get 100, 10, and 10? So what you can do is, if you can just break it down, this is 10 times 10. You can go ahead and circle these right here and move them outside of the radical. And it'll give you the same answer. All right. So let's go ahead and talk about a more complicated example. A more complicated example would be trying to find the square root of 5 square root of 32 p cubed z to the 4th. Same concept as what we did above. You're going to take your number, your coefficient, and you're going to break it down. 32 is 8 times 4. Doesn't matter what you start off with. Break it down. Can't break this down anymore because it's a prime number. Prime number, prime number, not a prime number. Prime number, prime number. I'm also going to break down these variables. P cubed, if you understand powers, means that you have 3 p's being multiplied by itself. Z to the 4th, how many z's would you have? 4 z's. So if I was to rewrite this, I'm going to need a very long radical. It'll be 2 times 2 times 2 times 2 times 2 times p times p times p times z, 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 z. And just to check myself, I always try to check myself. I'm going to do 2 times 2 times 2 times 2 times 2, and I should get 32. And I do. So I know I did it right. Alright, so a square root means that there's an imaginary what number here? imaginary 2. So that means that I have to circle groups of 2 to move out of my house. I have 2 2s here, so they're going to move out as 1 2. 2 2s here. I do not have another 2 anywhere in here to pair it with this one. So this one is going to end up staying at home. I have 2 P's. A Z. And another pair of Z's. So if I was to rewrite this, I will have the 5 I already had times the 2, the P, the Z, and then inside the house I had a 2 that never got married and a P that never got married. So my final answer is 5 times 2 times 2. 5 times 2 is 10. 10 times another 2. 20. I have a P. 2 Z's, so a Z times Z is Z squared. And then what was left? 2P. And that is my answer. How could you do it the shortcut way? Well, you could start off with what you had the first time. Figure out what are perfect factors of 32. Perfect factors of 32 means what two numbers can you multiply, and when you multiply them, one of them is a perfect square root. 16 times 2. So 16, if you think about the square root of 16, the square root of 16 is 4. So you have the 5 that was already there times the square root of 16, which is 4, and then you have a 2 left over. And so now your answer would be 20 square root of 2. And then what you can do is you can look here at your P's and your Z's. You need 2 of them. How many 2's go into 3? There's just 1. 3 divided by 2 is 1. And you have 1 left over. So that means you have 1 P outside of the house, and then you have 1 P inside. Right here, you have 4 Z's. 4 divided by 2 is 2, and it's perfect. So you have Z squared outside, and inside you don't have anything left over. You don't have any remainders. So your answer would be 20 P Z squared square root of 2P, which is what we got down here. If this confuses you, if you do not understand what I just said, ignore it and stick with this method. Alright, the last example. I have to simplify this. Alright, if you already think you know how to do it, just go ahead and ignore me. Try it on your own. Try to see if you can do it without me. If you almost have it, but you just need a little guidance, or you don't understand it still, pay attention as I explain it one last time. What you're going to do is you're going to look at the coefficient, you're going to look at the number, and you're going to break it down. You're going to find all the factors. What numbers multiply to get you 216? This is a big number. I'm going to go on my calculator, play around a little bit. If I do not know, any 2 numbers to start you off will help. I know that 8 times 27 would get me 216. Alright, I'm going to then take these numbers and break it down the same way I broke down 216. What two numbers will multiply to get you 8? 4 times 2. Can 4 be broken down anymore? Are there two numbers that multiplies to get you 4? Yes. 2 times 2. Can 2 be broken down anymore? No, because it's a prime number. The only way you can break down 2 is if you do 2 times 1. We don't worry about ones. So I'm going to circle it because it can't be broken down anymore. This one cannot be broken down anymore. This one cannot be broken down anymore. This one can be broken down. The square root of, if I try to think of two numbers that multiply to get me 27, can you think of it? 3 times 9. Can 3 be broken down anymore? Nope, because it's just 3 times 1 at this point. Can 9 be broken down anymore? Yes. Can 3 be broken down? Can 3 be broken down? So, I have successfully written 216 into prime factorization form. Just to check myself, I'm going to go in my calculator and I'm going to figure out if 2 times 2 times 2 times 3 times 3 times 3 gets me what I started off with. 2 times 2 times 2 times 3 times 3 times 3. I did it right. I got 216. All right. So, that was beautiful. I can go ahead and write those down. I need to break down my variables. I have 6 p's. One, two, three, four, 5, 6. 5 d's. And 21 W's. If you want to write out 21 W's, you can. I am not going to do that. What I'm going to do is I'm going to realize that I'm going to end up having to take the square roots of these. So I'm going to end up dividing these numbers by 2. 6 divided by 2 is 3. So I can tell that I'll have 3 groups there. If I was to write it down here, just so you can see what I'm talking about. 1, 2, 3, 4, 5, 6. I know that I have to circle groups of 2. So I'm going to figure out how many perfect groups of 2 I have. And they're going to come out as 1. So I have 3 groups of 2 P's. Same thing with the D's. If I was to write out my D's, 1, 2, 3, 4, 5. I got to figure out how many groups of 2 I have here. And only have 2 perfect groups of 2. So all you really have to do is take the exponent and divide it by 2. And that'll tell you how many you have outside. And then when I take 5 and divide it by 2, you get 2. But 2 times 2, that's 4 of them that I really had. So I had 1 left over. With the W's, I know that if I was to write all my W's out, 21 divided by 2 is 10. 21 divided by 2 is 10. So I know that I have 10 W's that move outside of the house. And I have 1 W still left over. Because 2 times 10 is 20 and I had 21. So I know I have 1 left over. That's really what you do when you get huge numbers. Alright, so let me go ahead and figure out what moves out of my house with my numbers, with my integers. I have a group of 2 here. do not have another 2 to go with this 2, but I have a group of 3s. So I have 2 times 3 times p cubed times d squared, and then I have w to the 10th, and then left inside the house was a 2, a 3, a d, and a w. So my answer, 2 times 3 is 6, p cubed, d squared, w to the 10th power, divided by 2 times 3 is 6, dw. That is my answer. Please go back, write down each of the 3 problems that I just went over, and see if you can do it without me. You can replay the video, you can pause it anytime you like. See if you can do these 3 problems. Please and thank you. I'm going to quickly, very quickly, show you the shortcut way again with the number. If you look at this, 216 can be divided by 36. 36 is a perfect square. So if you divide 216 by 36, because remember, you're going to try to find the perfect square, the largest perfect square, to get you to that number. And so 216 can be divided by this perfect square. It's 36. So what you can do is take this 36, take the square root of it, you'll get 6, and look, that's what you have when you took the square root of it, and then this is what's left over, and that's what was left over under the radical. Alright, let me know if you have any questions.